Yep, I think we're okay now. Um,
hmm
Thanks everybody for your patience. The stream is now live. Thank you, AJ, for taking the time to joining us. Hello, everybody. My name is Ram. I am Chief Evangelist at Cloud Foundry, and thank you for joining us today. So we have a very exciting stream. Today we're joined by AJ, who is an engineer on the analytics engineering team at ING. I will let him introduce himself. But again, thank you for joining, and let me not keep you from the great content we have for you today. Over to you, AJ. The floor is all yours.
All right, thank you. Hello, everyone. I'm Miguel. I'm working as an engineer at ING. For those who do not know, ING is one of the largest banks in Europe. And today I'm going to talk about how we utilize cloud native build packs and how does Paketo help us during our migration, basically. So let me first start by introducing that, which is data analytics platform, and it's the platform that we are using, Buildpack. It is well, predecessor of that started just as a server rack running a Hadoop cluster on an office floor, and yeah, it was just a very small team of five, where I was not even there yet. And yeah, why do we have that? It's because data scientists want access to data and compute power, which that unifies those two things in a secure environment as required from a financial institution. So what we provide is modern open source tooling, significant computation power. Like we have 800 GPUs, uh, which are the cutting edge GPUs, significant computation power, strict security and compliance measures, and all disciplines of analytics in one place. Basically, you're a data scientist at ING. You should use that for accessing customer data, transaction data, and and analyzing them. Like internally, this platform is used by fraud team, KYC team, know your customer team. So our platform is actually stopping bad actors from doing money laundering, etc. And as an overview of that, data science and data analysts at ING need to process and analyze data in a tightly sealed environment that needs to be compliant. And we create data science environments with cloud native build packs to help data scientists do their work the ING way. Uh, for this, we are using build packs, and obviously with build packs, we are creating Docker images. We are also utilizing Paketo build packs, and we depend on them in many ways. And yeah, I will assume most people here are, uh, well, they know what is build packs or what is Paketo, but I'll still start with an overview. Build packs have been initiated by Pivotal and Heroku. Build packs transform your source code to container images with no need for writing Docker files. And we replace Docker files with cloud native build packs builders, basically. The Paketo open source project provides production ready build packs for the most popular languages and frameworks. And it also provides necessary tooling for creating custom build packs in case the production ready build packs that are already provided do not meet your needs or you need something more. And at ING, we created our own build packs for CUDA, JupyterLab, Fork, VS Code, and one of our internal tools, MLP. So data scientists can use the tooling they're used to on our platform. And here we have a very nice GIF or GIF I've taken from, I think, Paketo's website. It's on how it works. Yeah, it takes your source code. For each build pack there in the builder, each of them goes through the detect phase, and they're basically dependency tree. And those who are picked, those who decide that they'll join the build, join the build. And here's the build pack magic. Build packs rely on a deterministic build process, and determinism here is resulting in same shot 256 Docker layer digest. So like regardless of the previous layers, for example, let's say uh, you let's say you have multiple layers. You have layers A, B, and C, and they're stacked like A, B, C. And let's say your build process starts with A, goes to B, and goes to C, and layer A is doing something else, right? Its behavior has changed, so that determinism has broken. Like normally in Docker files, what happens is, like if your first layer changes, your other layers are going to get rebuilt, right? And with build packs, if layer A changes, layer B and C will still be the same, like as long as they don't rely on layer A. And yeah, container engines share these digests in an order with images. So one of the major benefits we get from this is uh, these Docker images now are using less disk size. So previously, like we had a counterpart of using Buildpacks, and it used to be doing some Docker file sampling. And the issue with that, like I'm not even talking about flexibility, right? The main issue was, one of the main issues was the huge disk size. You were changing first layer, and everything after that had to be rebuilt again. So it was not ideal, let's say. And the base image is also swappable without rebuild. So in case one of your OS dependencies, one of your dependencies in the operating system itself, for example, things you install with apt get installed, there's a vulnerability in that, right? There's a huge vulnerability, and you want to change it in every image you have built. Like it's very easy. You don't have to rebuild all your images. You just have to do a rebase command. It's very trivial. And in our case, uh, we have our base images. Like this is a bit outdated image. And right now we are not using Debian. We are using Ubuntu 22. On top of that, we have our Python layer, JVM layer, pip packages, Spark, PySpark, and yeah, for example, for Jupyter, we also need Node.js because Jupyter Lab depends on that, and also npm, and also our custom Jupyter Lab, and voila, we have our Jupyter DSBox image. Okay, so this was pretty much the summary of what Buildpacks do, and I want to move forward to what we do and how we do it right now. At ING, we as engineers are responsible for creating build packs and creating builders. Uh, we have, I think, like 5 or 6 build packs, and we are using a monorepo. Like all our build pack source code is there, and each time we change something, a new builder is being built. And next time a user is going to use our builder, they just need to run their build pipeline. So we create our build pack, and then we wrap them in a builder. What builder is? Well, builders are a collection of build packs. Basically, builders define what's the stack that's going to be used and what build pack that you're going to use in that builder. Like you can also define different orders. So your builder can be responsible for both serving Python applications and Node.js applications. It's going to be a single builder, but the build pack inside and the orders that have been defined is going to determine what's going to be built. So in our case, our use cases, okay, I'm an engineer, I create the builder, and I serve the builder image like it's on our container register, right? And like right now, our data scientists already use Git. They manage their projects and their code based on Git. And yeah, what we did is to provide them with a build template. We are using Azure, so we have our template, and we are providing one. We are providing a build template that's responsible for uh, pulling our builder, building those data scientist images with that builder, and publishing that image in our own cluster, basically. So these pipelines are essentially just using Pack with a uh, bunch of arguments that we define. So here you can also see the flow. This is the development pipeline. We have our Buildpacks Git repository, and on a push, our build pipeline is creating the builder, and it pushes the builder to Azure Container Registry. And this is a user environment Git repository. Like it contains the requirements.txt, a project.toml file if they want to, an app file, like whatever, everything, like all their projects. And when they do a push, the add-up pipeline uses the build template we provide, and that build pipeline builds all the images that are needed, and yeah, it pushes the build user environment and the cache to Azure Container Registry again. And currently, we are building 3 different images by default. One of them is for Jupyter Lab, one of them is for VS Code, and the other one is for Spark-based, the Spark executors. So it's lighter. So yeah, I want to mention about the build packs we create. The first one is the IPython. The interactive Python shells and interactive Python notebooks will depend on that. Like in this layer, we are installing shared Python dependencies that are required for Jupyter notebooks, not only Jupyter notebooks, but interactive Python notebooks actually, because like VS Code also supports notebooks, and if you're a VS Code user, you can also run your notebooks and develop your notebooks in VS Code. And yeah, we also have a startup script that we installed. And the next one is the Jupyter Lab, which is like the main product of our team, where users can access their data. Here we are installing Jupyter Lab with pip, and that pip build pack is what we are getting from Paketo. And we are doing some mandatory Jupyter Lab extensions. For example, we install a Jupyter Lab plugin that shows how much resources is being consumed at that point, because users are complaining always like, oh, my environment is very slow. Why not? Like it's crashing, but like, yeah, I just tell them, look at your CPU usage. You're doing something weird. We are also installing our Jupyter Lab configuration in this step. This Jupyter Lab configuration is also mandatory to keep it more safe and easier to use for our end users, because like this Jupyter Lab instance has to be a bit different than their local setup. So yeah, and we are also installing some example notebooks. For example, we are providing Spark support on our platform as well, and the Spark support needs, for using the Spark, you need to know how to launch Spark, because like each Spark configuration is different, right? You need to know how to point to master, how to get the Spark section, and yeah, we are also providing these example notebooks in this layer. The next one is VS Code, the code editor we all love, except the people who use Vim. Well, for VS Code, we are using open source code server. It is a fork of VS Code, but it's modified to run on web, basically. Well, it has mainly 2 components. One of them is the server, one of them is the UI, and the server is like, we are installing both of them during the build time. Here we are downloading the code server from GitHub using curl and extracting using tar. There's also the dependency delivery feature, like for Packet, I think it's coming from Paketo, I'm not sure. And yeah, we unfortunately couldn't use it because of an issue with the tar file. And yeah, it's also on our backlog to make a fix on either Paketo, like Packet CLI, or no, not Packet CLI, Packet library, or the code server. And here we are also installing default and user extensions. We have defined our own custom VS Code dependency format, like very similar to requirements.txt. It is a list of extensions, name of the extensions, or the URL of VSIX uh, URLs extension, and like we either just download them, or if there's a VSIX path, we download it and install it. And the other one is Spark. Well, data analysts, they love Spark. Data engineers, they love Spark, and they can't do without it. So we have to provide it. And yeah, our setup is a bit different than the most. We are using Volcano for managing our Spark executors, and our Spark is running on Kubernetes. So each Spark executor is actually a Kubernetes pod. And yeah, like in this build pack, we are downloading and set up. We download and set up Spark from Apache.org. Like we get the tar file and we put it in metadata.dependency, and we use dependency delivery features. So we are able to extract it automatically. It's very nice. Like also with the offline dependencies, I'm also going to mention that with offline dependencies, if it is in metadata.dependencies and if it conforms a certain format, uh, well, it's going to be downloaded during the build time for the build packs and the builder. So that dependency is also going to be in the builder image. So like you can even build an image with Spark build pack, like even if you don't have any internet access or internet connection. And it also speeds things up because you don't want to pull large dependencies each time and a user is building their image, right? Users want to uh, access their images very fast. They don't want to wait 40 minutes for a build, or they don't want to wait for for an for a dependency to be downloaded. So caching is also important in different layers. Like uh, we are caching this Spark tar file basically in the builder, and after that we are also able to cache the installation as well, like in the cache image. And yeah, we also install PySpark, so it's how we communicate with the Spark cluster. And yeah, this is used by Spark executor pod. This is a like very critical part of our system. Okay, this is actually very interesting. We are also installing CUDA toolkit. And you may ask, like, why is this interesting? Because uh, CUDA installation requires you to have root. And like we started doing this uh, before there was a cloud native build pack extension, right? And yeah, we need to install this. This is a huge thing, and we need this because our end users want to use their GPUs. Our end users want to run their PyTorch models on GPUs. So we need to install this toolkit. So how do we do it? Well, uh, okay, CUDA is actually, you can separate it in two parts. One of them is the driver, which is mandatory for being able to connect to the GPU for GPU access, and the other one is the toolkit. The driver part is being handled by our Kubernetes operator. I don't know what operator that we are using, but there's an operator on our Kubernetes cluster responsible for the for abstracting our GPUs from the end users, and so we can easily mount those GPUs in our pod template. So in this build pack, we are installing CUDA toolkit without root access, basically. But like, yeah, it's actually not that straightforward because normally when you decide to install CUDA, it requires you to have internet. But the thing is, NVIDIA is actually providing a run file that's like for offline usage. that ROM file is actually shell file, and they embedded all their stuff in that shell file. It's like 10 gigabytes of bash script, and it has like all these tar files and other dependencies, all the binaries encoded inside. So we put this ROM file in our metadata.dependency. So that dependency is downloaded during our builder build. And when a user is building their environment, if they set the flag enable GPU in their project.toml file, if they set the flag, the detect phase of this CUDA Buildpacks passes, and they install the CUDA drive or CUDA toolkit. And the other thing is like, because this is too large, like, yeah, you also need to be considerate of the different life cycles of Buildpacks, because sure, you extract this, but this extracted thing is going to be converted to an image, right? But it's like, yeah, I think it's very close to 10 gigabytes or 8 gigabytes. And like converting this 8 gigabytes to a Docker layer is also taking some time, unfortunately. So this is another one, or well, we have a machine learning platform in-house. This is how data scientists deploy their models to production. This is an internal tool. It's like, yeah, normally by default, it uses Docker. So, well, it uses Docker to simulate the production environment. So like it also comes with all the dependencies it needs. And yeah, users normally have to have Docker installed on their local devices if they want to use MLP or test stuff out. But what we did is to install this as a build pack. Like we got rid of the Docker dependency, and instead of that, we basically copied and pasted. We basically converted the Docker file into a Buildpacks Go file. And yeah, just a sandbox environment for data scientists. They just write the command, and it spins up their machine learning platform sandbox instance on their development environments, DSX environment. We are downloading this from other artifacts, so yeah, it's a bit complicated. We have to do some pipeline juggling to make it work for the environment variables, because the Azure Artifact CLI tool expects some environment variables to be present for it to function and pull stuff properly. And we are also using our own custom stacks. Like as base, we are using Paketo, but on top of those, we need to install some custom stuff that can't be installed without root, and that are going to be needed basically in every image. So like if the detect phase is going to change no matter what, and user's input is not going to change the output, we install it in our builder or runner images. And yeah, we essentially install our certificate. And yeah, for example, we are mounting S3 buckets in our DSX environment. For mounting them, you need to have S3FS. And yeah, Fuse file system doesn't play very well with non-root. So that's how we install that in our stack. From Paketo, we are using a bunch of Buildpacks. We are using CPython, where we heavily depend, and users are actually customizing the behavior of CPython, right? Some users are using Python 3.7. Some users are complaining why they can't use Python 3.6. I say them, well, it's deprecated. Some people just use Python 3.10. And yeah, like all data scientists use different versions because they develop their project in that specific version. And yeah, I'm also encouraging people to stop using Python 3.6. But anyway, we also have the pip build pack. It is essentially needed in our images because we are doing a lot of pip installs. And we also have the pip install build pack, which installs the contents of requirements.txt in the image. We are also installing Node Engine, which is required for Jupyter Lab because Jupyter Lab wants Node.js. The Adaptium, which is needed for Spark because Spark wants Java. And our techs are run Gemifuel and build Gemifuel, which we migrated last week from Ubuntu 18. So it's a very live thing at our team. Like not even us, but other teams are even using this. Uh, yeah. So some cool stuff. This build pack stuff is like our build pack setup is, I think, easy enough for non-technical colleagues. We set up a very detailed and very easy to follow documentation on how to create their environments. And yeah, from what I heard, it's easy enough. And like right now, I think 50 custom environments have been built outside our team, and only 2 users required help. Yeah, so I'd say that's the win. And it's also flexible enough for the more technical. For example, some more technical people like figured out how to download Python dependencies from other artifacts. And yeah, some of them, as I said, are even trying to run their environments with Python 3.6. And also, like Paketo code base is just amazing if you prefer reading code instead of documentation. Like instead of reading the documentation, yeah, sure, you have to read the documentation of Cloud Native Buildpacks to understand what it does and how it works. But if you want to create your own Buildpacks, just go and read their code. Their code is like obviously following the best practices, because Cloud Foundry and Paketo is one of the uh, leading firms in this, leading organizations in this Buildpacks. And yeah, like if you read their code, if you read their code base, you can even clone one of their code base and like make the changes as you need. And offline dependencies also make builds very faster. Like you, for example, I just told you the CUDA toolkit is like 8 gigs. No user is going to wait for 8 gigabytes to be downloaded from the internet, right? It's just in the image, you are already pulling the image, and the image is way closer to the build pipeline than NVIDIA server. And also for other stuff as well, for Spark as well. Uh, and also automatic download and extraction of dependencies is like very cool. This is going hand in hand with offline dependencies. And the tools and libraries you need are Packet. Like pack is the command for creating uh, your end image, and Packet is the library you need for creating build pack, and Gem is the tool for creating builders, and yeah, also for creating build packs. And yeah, on top of these, I think we also need more open source build packs from other vendors. Like right now, it's mainly Paketo, and it's difficult to find build packs that are not done by Paketo. We are actually using a build pack from like another open source build pack that's not Paketo. We are using for app install. I think it's from Pagiani. And yeah, I definitely think we need more open source build pack. And our experiences, yeah, this was a redesign from scratch as part of migration from our Polish data center to ING private cloud. Previously, on our previous data center, we had a GitLab running, and on that GitLab, yeah, we were building Docker images from Docker templates. Yeah, there was something running. It was nice, but it wasn't really scaling well. And yeah, the company decided that we are going to migrate to ING private cloud. And yeah, we had to get rid of GitLab and move to Azure. And yeah, our previous architecture was also very tightly coupled with GitLab, so it was not going to work. So there was a complete redesign from scratch. And yeah, thanks to that redesign, we are where we are here. This is also giving a lot more flexibility to users for defining their environment. Previously, we were giving them options, right? For example, yeah, I'm just giving the numbers and the versions, but I can't really say for sure because I didn't memorize it. But like, for example, if you want Java 11, you couldn't get a Spark specific version because we were building different combinations of those dependencies, like they were being pre-built, and users like those pre-built things were the base images, and on top of them, we were installing users dependencies and we were bringing users code base. So like it was quite limited in flexibility. Like for example, right now there's no limitation. A user can use whatever Java version they want and whatever Python version they want, mostly, or yeah, whatever Spark. But previously, unfortunately, that was not the case, and it was also, as I said, consuming a lot of disk space. But right now, users have much more flexibility. We also have way faster build times on top of the less disk space, because previously, like building all the different combinations of images were taking hours. Like I'm not saying this lightly, it was like 4 or 5 hours to build all the combinations, and it was horrible. Uh, let's say there's a new Python version, right? The Python 3.12 is around the corner. It might even have been released. I don't know. For supporting that, you have to rebuild all the images for 4 or 5 hours, and yeah, that additional version is going to cost you, I don't know, maybe 1 or 2 terabytes of disk space, which and that disk space can actually be used for storing data, which data scientists and analysts really appreciate. Challenges we have overcome: shared data access inside user environment. Well, this was a challenge because our users are working as teams, right? And as a team, there's a de facto way of sharing your code. It is Git, and it's simple. But when it comes to data, it's more complicated. There's not a single way. And yeah, this was a challenge we had to overcome. And one of the ways for sharing data is S3. So we are mounting S3s in users' environment, and users are able to collaborate with their teammates using both S3 and our Azure Git. And also working with a framework that had limited documentation, like usage size is amazing, but developing new build packs, yeah, reading the source code helps you more than the documentation. And this also required us to invest more time in researching and learning how to use the framework effectively. And also enabling GPU processing from inside user environment was a huge challenge because we had to figure out how to do it. It's like we don't have root access uh, with Buildpacks. Like with Buildpacks, your build is done as a user. Like as a user, you're installing your dependencies in different paths. You're not installing them as a root, and you're setting your environment variables to proper places. So, and drivers most of the time need root access. So it was a bit of a challenge, but it's a challenge we have overcome. And yeah, challenges you overcome are what makes you better. And we still have some challenges. We need to harden isolation of user resources inside the cluster, and the network impact of the sheer size of data we are pulling from our data stores is petabytes. Like, yeah, our data store is crashing almost every day. Our ECS cluster is crashing because of the network. It's petabytes of data. And also the large amount of disk space required to build GP build pack with all desired drivers and plugins while building it on default as a public cloud agent. Like, uh, yeah, I'm going to assume most of you didn't work with Azure public cloud agents, but they, they have very small disk capacity. It's 10 gigabytes, and one of the dependencies we install is 8 gigabytes, so it's quite a challenge. And our future plan says, yeah, improve on the product as our adaptation increases. We want to offer DAP as analytics platform for the entire bank, and we want DAP to be de facto data analytics platform. in whole depth. So our end goal is to provide end-to-end analytics for 50% of ING globally in a secure and self-service platform. And self-service part is also very important for us because like hundreds of people are using this, maybe thousands are people, engineers, analysts, scientists, and bank clerks are going to use this. And there are only so few engineers, so it needs to be self-service and easy enough for users. And yeah, we also want to contribute back to the open source. For example, we are thinking about open sourcing the CUDA Buildpack we created to offer GPU processing for other companies or other individuals who also want to utilize GPU. Like also considering the rise of AI again, especially with the LLMs. If you want to like their Docker images, sure, but Buildpacks are not really utilized well enough, I think, on that front. We also want to contribute features into the Buildpacks library. For example, we want to add broader checksum support. Right now, it's only SHA-256. We also want to introduce more flexible pairing and unpairing behavior. This is especially for the dependency delivery part. And yeah, I also want to create an alternative to install Buildpack because right now it doesn't really take into account your Python version, and its cache can be just better, I think. So it's also one of the things on our roadmap, and I'm also thinking of contributing it back to open source and giving it back. Thanks for listening. Thanks for your time. Yeah, I think if there are any questions, I can take them.
Hey AJ. Yeah, I think that was a great presentation. And I think it's a lot of information to just get in about 30 minutes to. But yeah, it was fantastic to see all the different things that you folks are doing. I mean, I would imagine that people would go and fork like a Python build pack and do things, but a Jupyter notebook build pack and like a Spark build pack and like the CUDA build pack too. Those are things that I, didn't even imagine that I'd come across. But yeah, thank you for sharing all of that information about the wonderful things that you folks are doing. Are there any
Thanks for inviting
specific?
me.
Sorry.
Yeah, I'm listening. I said thank you for inviting me. Yeah, I'm listening.
Oh yeah, of course. Um, so by way of background, um, AJ and one of his other colleagues, I don't remember who exactly, was going to
He's Martin.
Martin, were
Yeah.
both presenting this as a talk at the ING booth in KubeCon. So I was at the Cloud Foundry booth, obviously, and I hopped over to say hi. But the thing is, their talk started at the exact minute that the booth doors actually opened to the public. And so there was like, I don't know, 100 people outside the gates waiting for free t shirts, and they all came rushing in. And so I couldn't get away from booth duty at that point to be able to listen to the talk. But obviously, AJ, you were kind enough to come and showcase all of that and more. Um, on the live stream here, and hopefully we're able to reach a lot more people and get folks to participate online and interact with this. So we have some questions. So Anthony Dahan asks, is it possible to use Jython instead of C Python? At least your JVM install would serve two purposes.
Hmm.
Do you have an
I don't
answer?
know. Uh, hmm. I don't know really. Like I didn't even think about that before. Our our JVM is mostly focused on Spark, and I think just C Python is easier for our end users. Like I don't know how the migration would look like. I also didn't use that before, so I really don't know.
Okay, something to potentially research.
Yeah, definitely.
Thanks for those inputs, Anthony. Mirko Francuski says, "Thank you so much for the presentation. Very interesting stuff." So, yeah, I think overall the session seems to have been well received. Again, if for folks who are watching live, if you have any questions, do drop them into chat. I'm happy to bring them onto the stream and get them answered.
Yeah.
So,
And also, you can reach out to me at, I don't know how to pronounce it. You can reach out to me on LinkedIn, or you can email me. My email is this with English letters at uh, ing.com. I should have written it somewhere here. Never mind. You can also find me on LinkedIn and shoot your questions there if you have any.
yeah, thanks for that. That was going to be my follow up question about how best to reach you. So, yeah, do reach out to AJ on LinkedIn or email. It's first name dot last name. Use English letters at ing
.com.
dot com. So,
You know what? Let me, yeah. Yeah. I also added my email there if this is visible.
yep, thank you for that. I don't see any more questions on the live chat. So, hopefully people had a wonderful time or were extremely bored. But I think it's the former. Um,
I
probably,
hope so.
I hope so too. But thanks for your time, AJ. Again, it was wonderful having you. Thank you, everybody, for joining us from different parts of the world. This stream is obviously going to be available on YouTube. You can go back and forth and listen to it and share it with anybody else who might be interested in build packs, custom build packs, doing machine learning platforms using build packs and the like. Thanks, AJ, for your time. Hopefully, you're able to
Thank you
join
for
us.
hosting.
Sure. Hopefully, you're able to join us in the future on another stream someday.
Hopefully.
Thanks. Bye
All
bye.
right.